Hello friends, welcome back to my channel. In our last video, we have learned about how to convert a speech to a text through Assembly AI. Today we'll be learning same thing through a Sphinx API. So Assembly AI, it's a cloud-based platform where we have to use their API key to use their API or invoke their API, and we have to pay some money for that. But this Sphinx API is an open source project which we'll be using today, and for this one we do not need to pay any money. So without paying any money we can do the same thing uh, using Sphinx API. So without wasting any more time, let's dive in. So this is the Sphinx API. Sphinx 4 will be using. This is comes with a package edu CMU Sphinx. We need this particular dependency from Maven. Let's see the code what we need. So this is the same POM where we are keep adding new stuffs in every video. So if you are first timer here, if you haven't seen our earlier videos, please go and check the earlier videos so you'll have overall idea how we are developing this project. So this is the same POM which is Spring Boot Spring Boot service. So we need this dependency for this Spring Boot starter web dependency. So this is a Spring Boot project running on JDK 17. These are all these things, means you can add these two dependencies as well, dev tools and starter test. All these dependencies we have described in our previous videos where we use them. For today's video we don't need them, but we need these two dependency for today's video. Sphinx for core and Sphinx for data. These two artifact ID we need, means these two dependency we need. So this is the version we are using. So Sphinx for core, Sphinx for data. These are the two dependency you need to add for today's implementation. And then this POM is same whatever we had earlier. We don't need to add any API, as I say, API key. As I said, this is open source project, so this dependency itself is good enough for this project implementation. This is the endpoint we'll be using today. So this is API v1 audio to text through Sphinx API. This is my endpoint. So I have created a speech to text service and I am calling that one. The method is generate text. So I'm passing, and again I'm passing the file path, which is a recorded file. For this one, Sphinx API, we need to use a WAV format of the audio file, because MP3 final it doesn't support MP3 format. So if you are passing MP3 format, somewhere you have to add extra code to convert it into WAV format, WAV format. I believe, yeah, it doesn't support MP3. Means that's what I don't know. Like, if these days it's supporting, but what I knew it doesn't support MP3. So now I'll be passing a WAV format of the audio file. So this is the implementation. I have created an empty string result. I have created a final result as a string buffer. Creating a configuration. The configuration I'm adding these three things. One is resource edu. So this will be coming from that data dependency. Means we have the Sphinx dependency, right? It will be coming from that edu CMU Sphinx model. So it will use that ENUS model. Resource, it will use this as this dictionary DICT as a model. So dictionary path. So this is the set dictionary path. This is the acoustic model path. So in which language it will means which language it will read and text. So that's the model path. This is the dictionary path. This is as is, you have to provide whatever I have provided. You don't need to change anything here. Then language model path is enus.lm.bin. So these are all hard coded things you have to pass as a configuration. So now our configuration is done. We have our configuration done. Now next one is stream speech recognizer. So we are creating this object stream speech recognizer. This is coming from that Sphinx dependency, and we are passing that configuration. Now this file path, which is our audio file, we are creating a stream out of that audio file. And then this recognizer is everything, right? This is which we have to call and start recognition. So this will now start uh, recognizing our audio stream or the audio file, and then we can call recognizer.result, and if that result is not null, we are adding it into this string result, and we are printing it here. And in next line, what we are doing is in that string buffer we are appending that with a space. So if it is a big audio file, it will recognize a small portion at a time in a chunk, a small little chunk it will recognize, and then it will uh, returning that chunk as a result, and then I'll be adding it into the final result and keep adding it. And then once our whole file recognition is done, we can call, or we should call, recognizer.stop recognition. So we don't need this recognizer anymore. So we'll stop that process, and that way that program will stop here, and then it will means this recognizer will stop here, and then it will be passing the final result to the caller method, means whoever will call this method will be passing. This portion which I have commented out, this is basically now at this point here, if you see, I am passing a already pre-recorded file, but instead of pre-recorded file, you can use a live speech. So this code is for live speech. So if instead of file you want to uh, transcribe the live speech, you can use this program. So same configuration we are passing, and we are creating basically live speech recognizer instead of a recognizer. So this is a stream speech recognizer. These are the two differences. This is stream speech recognizer for pre-recorded file, but for live speech or streaming thing, we have to use this class, a live speech recognizer, and that's what we have to create by passing this configuration. And then we have to use that recognizer dot start recognition true. This will start it, and then you can speak through a microphone, and then recognizer dot get result will same thing, right? It will break it into chunk whatever you'll be speaking, and then it will be showing it, and then you can do anything with that. So this is basically, I just commented because we are not going to do that, so I've commented this one out, but you can try this one. We'll be testing a pre-recorded file today. So this is the code. I hope you understood this implementation. So now let's dive into the execution of it. So I have created a audio file test.wav, which will be passing wav file. So I'm passing this file, and I have to, let me build it. I don't know last time when I built it, and I'll to run this application. So this will be interesting. If you will see how it is breaking the whole audio file into chunks and keep adding it into the final results. We'll be seeing it here because we have added the print of the chunks, right? So now it started. I will pass this audio file, and I'll go back to the program, and we'll see what's happening. So yeah, this is all initializing everything, that configurations and all we gave. So it's initializing speed tracker, it started. If you see, hi friends, welcome back to the channel. So it's breaking it into chunks. If you are new here, so this is another chunk, and don't forget this is another chunk today. So these are all chunks and getting added to that Spring buffer. Text to code. I think this is done. Now it's all done, and I'll see what we have got. So we have got the result. The final result is here. Hey friends, welcome back to my channel. Welcome back to the channel. If you are new here, don't forget blah 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 blah. So this is what we recorded in that audio file, and same thing we are transcribe here as a text. So this is very cool project. Without paying any money, we can use this open source API and transcribe any audio or any streaming into text, and then we can use it for any other purpose, whatever we like. Hope you like the video. If you like the video and if you are learning anything out of my video, please subscribe my channel and share it with your friends. Thanks. Have a nice day ahead. Bye.